All right, I think we're logged in here. Let's go ahead and kick this off. So thank you everyone for joining A42 Lab's first webinar of 2021. Today's presentation will be by A42 Labs data scientist Jessica Rudd. Since joining A42 Labs, Jessica has been focused heavily on AI ethics. As part of this research, the topic of safely sharing sensitive data has come up frequently. To address this issue, we've developed an innovative software solution based on generative adversarial network, or GANs. In today's presentation, Jessica will provide you with an overview of this research, share some results, and review additional applications for future research. I'll hand it over to you now, Jessica.
Thanks so much, Jared, for the intro. It's really great to talk to everyone today about this exciting use of synthetic data generation for improved data security. So I think we're all becoming aware that the proliferation of AI algorithms has led to growing concerns over data privacy. If you've used an app or clicked through the terms and conditions allowing your data to be used by the application, you may have noticed some verbiage that indicates, hey, we're going to use your data, but we're not going to use some of the identifying information. We're going to kind of get rid of that. So it's definitely an issue that's out in the world. With these concerns over data privacy, in turn, this has led to stronger consumer data privacy and protection laws in the EU with GDPR, as well as US jurisdictions, including California and most recently Virginia, which have implemented similar things to the GDPR nationally. By restricting access to this information, a certain amount of individual protection may be gained, but it comes at the cost of the algorithm's effectiveness because we're effectively doing things that may lose information for effective algorithm training. Privacy regulations also limit and slow down access to useful data, essential to research and development. For example, teams that require cloud resources, such as GPUs for large, complex modeling problems, there's an added complication of securely moving sensitive data into the cloud for this purpose. We're talking about moving data, but why would we move secure data in the first place? Why would we need to do this? As organizations scale their data science capacity, there may be a need to share data to support additional business applications and state-of-the-art research and development. Data may need to be moved internally across teams and verticals or shared with external vendors for this purpose. There's also the additional consideration of potentially sharing data with academic partners or public content sites such as Kaggle for potential R&D value added. So essentially, we're figuring out how do we collect and move real data. It's very complicated, and certainly as the size of data grows, the level of difficulty increases. We want to ensure data privacy while also being able to share the microdata that is valuable to our algorithms. So how do we move sensitive and personal data within and across organizations without concerns of privacy regulation? So there are some existing solutions to address the data security problem. Like I said, with the terms and conditions you may click through, there's this idea of anonymization, which is the masking or elimination of identifying characteristics. However, we do know through some research that with as little information as just your zip code, gender, and date of birth, individuals in the US can be identified an average of 81% of the time. Another paper back in 2007 actually showed that just a few movie ratings on Netflix can identify a person as easily as their social security number. So we've seen that combining data from multiple sources, it is possible to form a surprisingly clear picture of our identities, even if there has been a degree of anonymization. A lot of these articles that came out around these studies basically said, anonymized data can never be totally anonymous. Encryption or hashing of data, random tokenization, it's great for security purposes, but it does remove statistical properties from the data that may be valuable for ML model training, also degrading performance. So at A42 Labs, we've built an automated product solution that addresses the data security and privacy challenges discussed previously by leveraging something known as a generative adversarial network for synthetic data creation. The GAN model architecture was initially introduced by Ian Goodfellow et al. In 2014. And it essentially uses these dual learning neural networks, the generative model and a discriminative model working in tandem. So it starts with random input that is structured to be similar to the size and structure of your original data. And the generative model learns the distribution of data, including the multivariate relationship, and generates synthetic data as close to the real data as possible through multiple iterations and the backpropagation learning process, effectively minimizing the loss or the difference between our original data and our synthetic data. At the same time, the discriminative model, it estimates the probability of the created synthetic sample being real or fake. It's essentially a predictive model that's trying to predict yes or no, whether the sample is real or fake. With the global goal here is essentially that we want the discriminator model to maximize loss so that we're saying it cannot effectively distinguish between real and fake. Basically, we want our discriminator model to be like a bad model with 50% accuracy, effectively a coin toss, that it can't even tell the difference between the real and synthetic data. The discriminative model then, the GAN model itself, from a global perspective, is discovering the structure in the data that allows them to make realistic data. The fact that we're creating realistic data through this synthetic generation process is really useful, especially when we're working with data where the structure itself and the relationships might not be well understood at the outset, right? So it's discovering those structures and relationships through the learning process, even if we don't know them ahead of time. And while GANs have been widely used for synthetic image creation, we can extend their use to additional data types and uses, such as for structured data creation. So our synthetic data generation product takes a data file and runs an automated process to clean and pre-process the data and prepare the data for the synthetic data generation process. The GAN model then randomly generates an initial synthetic data set and iteratively updates and compares the feature distributions of the synthetic and original data until a specified like statistical threshold or a training time cutoff is achieved. So like for our MVP purposes and testing, I built the model to cut off after 5,000 epochs of training. The statistical and mathematical structures that are learned from the GAN are then saved and returned simply as a model object, which can then be safely shared and used to create synthetic data according to someone's specifications, how large they want the data set, for example. And this automated solution also returns a results dashboard with key metrics that include the statistical quality measurements of the data so that we can confirm, this actually is a high quality synthetic data set that closely follows the original structure. And also we want to confirm, since this is all about data security, that there are no duplicated records. Essentially, we want to confirm that the synthetic data generation process doesn't reproduce any real records. So in our MVP, we pulled a test for a credit fraud application, and ran this process on a credit fraud data set. And you can see after, even though I ran it on 5,000 epochs, even earlier on than that, the generated data on the left, which is an image that represents kind of the global distribution of the whole data set. The left image is the actual fraud data, and the right image is the synthetic data trained over time. You can see that the generated data eventually follows the actual fraud data distributions after several training iterations. On the right of the screen is the cumulative sums per feature with the real and synthetic data overlaid on each other. And this shows that our individual features of the generated data also closely follow the real data distribution. So that we know not only from a global scale of the whole data set, but our individual features, which are important it could be important on an individual level, also follow the original distribution. And of course, like mentioned, we tested whether there's any data leakage through checking for duplicated records between the real and synthetic data, and there are 0 duplicated records. From a statistical standpoint, the correlation coefficient between the real and synthetic data is 0.98. So we know this is very high quality data. Now, of course, we want to create realistic, applicable synthetic data that can be used for testing purposes, building, training machine learning models, things like that. So it's important to know that using the synthetic data also is high quality for, these purposes. Just looking at model performance in a basic logistic regression for this data set, the real data performed with 0.98 accuracy, whereas the synthetic data performed 0.95. So really similar results for both data sets, which so would remain really quite usable for this purpose. So I think we're starting to see like some of the benefits of using GANs to create synthetic data and just generally using synthetic data for data security purposes, right? Generating synthetic data makes the data available sooner rather than waiting for like lengthy and expensive data collection and anonymization processes. And we've already pointed out that anonymization itself is not quite perfect. The synthetic data preserves the original characteristics of the real data, and the data can then be shared and models trained without revealing this sensitive information. So you're training your models on data that is realistic to the original data, but you're not having to share the original data. So while the synthetic data set has the same mathematical and statistical properties as the original data set, we know that it does not explicitly represent real individuals, and we make sure in this process to confirm that through checking for duplicated records and data leakage. So essentially, you can think of this as a digital mirror of real-world data that is statistically reflective of that world. It enables training AI systems in a completely virtual realm, and it can be readily customized for a variety of use cases ranging from healthcare to retail, finance, transportation, and agriculture. So we've discussed one important use case of synthetic data generation specifically for data security, and I think we've seen some of the benefits of that, but there are many additional applications that can provide business impact. For imbalanced data, for example, and actually the example that we tested on with credit fraud, right? Very imbalanced. Many of the high cost conditions of interest in specifically the financial sector, such as fraud, are very rare events with highly imbalanced data sets. Training the predictive models on small and or imbalanced data sets can lead to biased models with less than ideal performance. So in this case, you can actually use a GAN to synthesize the specifically rare events, right? You can synthesize realistic fraud events that then you can augment your original data set with, assisting kind of the improving the challenge of your imbalanced data. Kind of slightly related to that is this idea of edge case simulation. So just like, fraud data is very rare, some collected data just simply does not contain every possible scenario, which can affect the model performance negatively. In such cases, we can include those rare scenarios by officially generating them. So a really good example of this is for a self-driving car project. If you want to handle the case when someone suddenly comes in front of the vehicle, kind of collecting this information in a real world situation is risky and probably unadvised, but you still want the model to be trained to account for that. So in this case, we can actually create a synthetic record of that potential event, so that the model can be trained kind of on that event, hopefully not, but on that possible eventuality, right? Synthetic data could be a case for removing collection bias. So the synthetic data we know is only as good as the original data it's trained on. However, if we know of embedded biases or gaps within the data, such as certain populations not being well represented in the data set we want to train on, we can simulate records that help fill these gaps. Additionally, and I think I've hinted on this a little bit, is this idea of ML data compression. So, you have very, very large data sets we could be working with. And even if you're not even considering the security risk, just moving large data can be very difficult. But since this process produces simply a model object, which is a small file, which then can be used to initiate or instantiate the synthetic data generation, we can just share the model file rather than transferring large data files. Increasing data volumes, again, like the idea of small data being an issue for training some problems, training some models. Collecting and modeling tremendous amounts of real data is time consuming and can be expensive. My background is initially in public health. And so I'm really aware of certain situations that it's very rare to have large data sets available, very time consuming. Think of like trying to get a training data set on labeled X-ray images. The ones that are out there tend to be pretty small because that's very expensive and time consuming to get clinicians to label X-ray images for certain disease outcomes, right? But we can generate synthetic data to make some of this data available more sooner on a larger scale. And finally, the idea of using synthetic data for the agile development and DevOps process. So for using this for software testing and quality assurance. Artificially generated data ultimately eliminates the need to wait for real data. So this availability of test data can lead to decreased test time, increased flexibility and agility during the development process. So it's just kind of a nice added benefit of this process. So the A42 Labs synthetic data generation service has been built as an automated solution for a set of commonly occurring business use cases. It can be deployed as a front-end UI on-premise or in the cloud for secured synthetic data generation within an organization's ecosystem and outputs an easily shareable model object, as well as a reporting dashboard of synthetic data quality and possible data leakage. For more information on this process and this product, you can, or early access, you can please contact us at info@a42labs.io. So thank you so much for your time. I hope this kind of sounds as exciting to you as it is to me. And if you have any questions, please include them in the chat.
Thank you, Jessica. That was fantastic. Really, really powerful solution here that you've pulled together, and I think adds a lot of value, or I know at least adds a lot of value in kind of how we work with customers, but also, the initial discussions that we have had with folks already. It's unbelievable how quickly this is kind of catching on here. I do have a few questions that kind of popped up, and I'll kind of run through these. The first we have is, why do people need to move sensitive data around?
Yeah, that's a really good question, and I can kind of expand on that. I think I touched on a little bit. So, we're in a realm of like the data science capacity is increasing like exponentially every day, right? And so scaling this capacity in organizations to be able to do kind of research and development and use the data that they have to kind of improve their bottom lines or their applications or their customer interfaces is kind of really important, and things are moving very quickly in this area. So, even within an organization, you might have one part of an organization that has some data, but now you have different verticals within the organization that can benefit from sharing that data, doing research with it, helping build products internally, and even working maybe with external vendors on this area to kind of expand their data science capacity, right? So I think in that case, it's really important to be able to utilize the information we have, but with while maintaining the integrity of that information, internally to the business as well as externally to its customers. And so I think the ability to kind of share realistic data for this purpose is kind of really important.
Yeah, totally agree. We see that happening all the time. As you know, being data science consultants, we're often trying to get in and quickly show value for our clients and customers. And very often security and anonymizing data, and this becomes the hold up, right? So yeah, definitely it will accelerate getting this data and then being able to get it in a format that we can actually build models on, which is great. What types of data are currently supported with the solution, Jessica?
Right. So our current automated solution has been kind of built and tested on a kind of a set of commonly occurring cases, like structured data cases. In this case, you saw a specific use case with financial data. We have like electronic health record kind of structured data that has been looked at. So kind of, your commonly occurring like structured data sets. There's a backlog that we have of additional data types that we're researching kind of the best solutions and architectures. GAN is really nice in that, it's very customizable. So you can customize the architecture itself for different types of data, making sure that you're accounting for sort of the complexities of the different types of data. So we have a backlog of these additional data types that we're working on to add as features to the product in the near future.
That's great. That's great. Question here is where is A42 software installed?
Right. So the software itself can be offered either as a deployed on-premise as a UI. Excuse me. That the customer can then use this process, kind of a very front end process to keep the data within their own ecosystem, upload what they need to the software, and it outputs the model file, like I said, and a nice dashboard kind of for their testing purposes. And that model file can then be used and shared in whatever way. It can then also be deployed in a cloud-based situation as well. If an organization prefers that, or that's more the ecosystem that they use, and that sort of expands on some of the capabilities in terms of like training capabilities and kind of the data science technology stack that is available within different organizations.
Fantastic. So if I understand it correctly, the software is deployed behind the network where the secure data lives, whether on-prem or in the cloud, doesn't matter, as long as it's behind your secure environment. And once in there, the model's built, and so the only thing that comes outside of the network or the secure environment is the simulated or synthesized data. Is that correct?
Yeah, exactly.
Perfect. So the next question here is what is involved in training the models? So do I need a data scientist in order to run this, or is this something that a business executive or a database administrator could do?
Yeah, so the initial like UI as described, an internal business analyst or executive could use for most data sets up to structured data set up to a few million records could be easily trained using the UI and just the internal CPU that's available, right? In the situation where you might be working with more complex data, over terabytes of data, then that's when you kind of have to start looking into more of like the GPU enabled technology stack, or moving things into the cloud. Now, the nice thing about the output that we get from the UI is that it points out kind of the quality of the data, right, that you're getting. And in that case, you're learning, okay, if there's gaps or things that can be updated on a more customized basis, that's where then like our additional like customized services may come in to make more high quality specialized data sets from that situation. But it's a great thing about kind of the initial like UI is it's built to work on most common data sets. But then it also kind of gives you the lead in into kind of more specialized custom experience given some, specific use cases that may fall like be edge case data sets that need a little bit more of a specialized touch.
That's great. And you kind of started to answer a little bit of this around the CPU and the GPU, but how long does it take to actually run and train the model and create the synthetic data?
Right. So in this case, the entire process, like the MVP that I talked about, the entire process takes less than 5 minutes.
That's fantastic. Okay, how is synthetic data as a service offering priced?
Oh, that's a really great question. So the offering is offered on a subscription basis at this time, and yeah, so we're more than happy to offer free trials for those who are interested, and if you want more information about it or have a conversation. Again, yeah, they can please reach out to us at info@a42labs.io.
Fantastic. And I have one more question here that came up. How do users know how similar real and synthetic data are? So I guess, how do you know how good the synthetic data is? I believe the question.
Right. So you're doing like the output kind of runs several statistical comparisons of the data. I quoted kind of the correlation coefficient, specifically the Spearman-Rowe correlation coefficient. And so we get metrics like that, as well as metrics that indicate kind of the performance similarities or differences on a couple of key like common machine learning models between the real and synthetic. And we also have available output that kind of does the correlations between the features so that you have comparative like heat map correlations of the real and synthetic data. So not only are our individual features kind of look and feel the same, but as many of us know, kind of the multicollinearity and relationships between the data and the data set also matter to our outcomes, right? So kind of looking at the cross correlations and the heat maps between the two, we can confirm that we're maintaining that structure of the data as well. So we're kind of covering multiple quality points on our synthetic data set.
Fantastic. And I guess I can add to that I know I've seen from your research too that you've actually trained some machine learning models on both the real data and the synthetic data and found the results to be essentially very similar there as well. So I think that goes to the point of this is really high value in terms of these machine learning applications on sensitive data. So thank you so much for presenting this, Jessica. This is very, very interesting work that you're doing here and also very high value. Coming up next in 2 weeks, we'll have another webinar by Kabir Doshi, where he'll be presenting some research that he did actually into generative adversarial networks and talk a little bit about that more on an introduction basis. So if this is interesting to you, please come and check that out. Also, in the meantime, if you would like additional information on GANs or any of the other work that's happening at A42 Labs, we post a lot to our blog and other materials out on our academy. Please check out our A42 Labs website at a42labs.io. And as always, you can reach out to us at info@a42labs.io if there's any questions. Thank you so much for your time.
Thanks so much.